So yeah, my name is Michael Erb. I'm an assistant research professor at Northern Arizona University. And my talk is about the wonder of weather. Just so you can get a better look at me without the mask, there I am. So I'm a scientist and an author. I got my PhD in atmospheric science from Rutgers University in 2014. And like I said, I currently work at Northern Arizona University studying climate of the past. So my main research focuses on the past 12,000 years. And I won't be talking about that today. We're going to focus on something a little bit more modern. And I hope you enjoy it. So first, I wanted to say that weather is amazing. So here's a picture of a supercell thunderstorm out in the Midwest, in a big lightning bolt coming down right in the middle. Supercell thunderstorms are our most intense and powerful type of thunderstorms. They have this great big rotating updraft. So if you can imagine driving your car along the highway and you look out your window and you see something like that, it would just be spectacular and perhaps a little bit concerning, depending on where you're going, but really cool nonetheless. And weather is important. We experience the weather every day. Climate varies across the world, affecting how and where people live. And one big element in climate is rain, water, like we see in the background here. Access to water is important to people. It's been important to us for as long as we've been around. So where we can get water for drinking and for growing crops and for other things does have an impact on where people live.
I know what it is. It's my fault because I clicked on it funny.
And severe weather can cause death and destruction, unfortunately. So it's something that we have to pay attention to and watch out for. And I wanted to start off just by showing you a few more weather photos. I didn't take these. These are probably in the Midwest, taken by the National Severe Storms Laboratory, most of them. So here's another supercell thunderstorm, a great rotating updraft. I think they look just spectacular. Here's a big lightning bolts in the Great Plains. Weather can be dangerous, like I said. Tornadoes can cause a lot of damage. Lightning can kill people and also cause damage. And obviously, stuff like flooding and hail, we have to watch out for. And for lightning, one of the expressions we have is "when thunder roars, go indoors." Just meaning, if you're outside, especially if you're somewhere exposed, when you start hearing thunder, go somewhere safe. Here's some big hailstones. Here's some hailstone damage. And meteorologists are people who predict the weather. So from there, I want to launch into talking more about Flagstaff climate. And to start, we're going to talk about US climate. Just give a very broad, very quick overview. So here we have average July maximum temperatures. So basically, what's a typical maximum temperature in July all across the country? And you can see that in the east, you have a pretty good south-north gradient where it's hot in the south and it gets cooler as you go up. But also it's affected a lot by topography. Where you have mountains, that affects your temperatures. Obviously, as we know here in Flagstaff, where it's 7,000 feet, we have nice cooler temperatures compared to Phoenix and Tucson. Here is average January maximum temperatures. So basically the maximum temperature you'll typically expect in January. And again, we have a nice gradient here. In the West, you have a lot more effects of topography. And also here's annual precipitation. Near the Gulf, you have a lot of water coming into the eastern part of the country. And along the coast, you have a fair amount of water. Once you get out west, a lot of places are pretty dry. We have fairly wet again in the Northwest. And to give you a better sense of Flagstaff and Arizona in general, I'm sure you know, but this is what our geography looks like. In the south, we have the basin and range, which is low elevation, largely desert. Then we have the transition zone, where elevations are rising. The mountains, the the plateau you're coming up to the top of. And then in the north, we have the Colorado Plateau, which is higher elevation. And Flagstaff is right here. It's kind of right towards the southern edge of the plateau. Yeah, go ahead.
Are you okay with us taking a picture of one of your slides?
Sure, yeah, go ahead.
Thank you. I want that one.
Yeah, and most all of these images are available online if you search around for them. But yeah, it's neat to see, you know, we're such in the middle of it that it can be difficult to get a bigger perspective on what the state looks like. So yeah, this is kind of just giving us some grounding. So let's go ahead and dive into Flagstaff. So welcome to Flagstaff. You all have been here, but let's dive into the climate here and the weather here. And to start, let's do 30-year means. So these are called climate normals. Basically, they're updated every decade. So currently our normals go from 1991 to 2020. They were just updated this year. And it just gives you a sense of what is the typical climate in a place. Now let's start with temperature. Here we have Flagstaff temperature. We have the average maximum temperature for each month, the average minimum temperature for each month, and the average temperature for each month. And there's no real surprises here. You know, it's decently cold in the winter. It gets warm in the early summer. Late summer is actually a little cooler. But really, this is kind of what you expect. It's not very exciting. But if we compare this to a different city, we have vastly different temperatures. Now, I haven't labeled this city yet. This city is about 25 degrees Fahrenheit warmer than us, pretty much year round. Any guesses about where this might be?
Winslow.
Oh, not Winslow.
Oh.
It is Phoenix.
Phoenix.
Yeah, so we have about a 6,000 feet difference. Pretty much every month is about 25 degrees warmer down in Phoenix. So if it's a cold day down here in up here in Flagstaff, head down to Phoenix. If it's a hot day in Phoenix, come up to Flagstaff. Okay, so let's go back to these normals. This is precipitation. So the one line's a little difficult to see, but this lighter blue line is snow. So snowfall, basically, once it falls, how deep is the snow? And you add that up. This other line is rain plus melted snow. So these have a little bit of overlap, but basically, how much moisture are we getting each month? So you can see we have a little bit of a peak in the winter, that's mostly from snow, and we have a bigger peak in the summer. And here we can put this all together. Again, not terribly exciting, but give you a baseline of Flagstaff climate. To get a little bit more interesting, let's take a look at this year's weather. So I downloaded daily data from the Flagstaff Airport from this website. This is the National Climatic Data Center, and they have loads of weather data about everything. And it's very easy to download just this climate data online. So I downloaded basically all the weather data I could get my hands on from Flagstaff Airport. And here we have daily Flagstaff weather in 2020. Now, the red line is the maximum temperature for each day. The green line is the minimum temperature for each day. These blue spikes are precipitation, total precipitation for each day. So again, like before, it's adding up melted snow as well as rain. And so to tell these apart, and it's current as of last Wednesday. So about a week ago, I could probably get a couple extra days. I was a little lazy. So yeah, it's about a week out of date. So let's add a little bit more data. This is snowfall. So basically I want to show this so you can tell what part of this moisture is snow and what part is rain. So basically you can see that up until, you know, maybe the end of April, most of this is snow. That's where we're getting our moisture from snow. Whereas after that, it's pretty much all rainfall. And there's a couple cool things to point out here. So here we have our 2021 monsoon so far. And I'll be talking a lot about the monsoon today. One nice thing about the monsoon is it brings cooler temperatures. You can see the early summer was quite hot. If you were living up here in the early summer, it was a little insufferable. But then once this water started showing up, you can see how the temperature very obviously dips, which has been very nice. That's one great thing about our monsoon here. And talking about that summer warmth, we had one day, this was July 10th, where we reached 96 degrees Fahrenheit. That's 1 degree off of our all-time record high here in Flagstaff. So if you were thinking, hey, this is really hot, you weren't wrong. It was very hot, which is why it's nice we've had such a wet monsoon. So let's add a little bit more data. This is about wind. So the green is wind speed. Here we have 0 to about 20 miles per hour are these peaks. And this is wind direction. For each day, there's a dot. Lots of dots are clustered around here, which is wind coming from the southwest. And this is not a true average. I couldn't find a true average. This is the direction of the strongest 5-minute wind speed. So it's a decent indication of where the wind is coming from. It's not perfect, but for the most part, wind comes from the southwest. And that makes sense. That's what I usually notice outside, but it does change from time to time. And probably throughout the day, you get different wind directions. And, this spring has been windier than, say, the summer. And living here in Flagstaff, that's what I often notice, is that spring is a fairly windy season here. Okay, so let's go back to the monsoon though. So how does this year's monsoon stack up to previous years? So here I have a figure. This is cumulative monsoon rainfall. So this is 89 years. Each year has a line. Each year starts at June 15th and goes to the end of September. And so you read this, every time there's a rainfall event in that year, the line ticks up. So this is a big rainfall event, it goes up a lot. And then by the time you get to the right-hand side, that's the total monsoonal rainfall for that year. So you can see the blue line is our strongest monsoon on record in 1986. We end up with about 20 inches of rain. The driest was last year, 2020. Of all the years on record, 2020 is the driest, which if you were here last year, doesn't come as that much of a surprise. It was very dry. And the average is about 7.7 inches. So where do you think this year is stacking up so far? Is it relatively wet, relatively dry, about normal? Yeah, about normal. Any other votes?
I think it's gonna be pretty close to that 1986 number.
Oh yeah, all the way at the top?
Well, not all the way to the top, but I would say between 2013 and 1986.
Okay, yeah, those are both good intuition. Here we are so far.
Shoot, I was way off.
So, well, earlier in the summer, we were above that 2013 line. We've had a little bit of dryness the past few weeks. We did get some more rain at the end of last week, which isn't on here, which would tick it up a little bit more. But if we get some more rain this month, I would not be surprised if we end up being the third wettest monsoon on record.
Oh.
But even if it's fairly dry this month, it'll probably still be somewhere in the top 10, which is pretty impressive. And one thing, it's a little difficult to see, but 2019 is the second highest. So both 2019 and 2020 are the two driest monsoons on record. So if you didn't like those past 2 years, the good news is that it's unusual. We hopefully won't get anything more like that. Okay, so we have a wet monsoon, more flowers. That's one nice thing. I took these pictures. This is Buffalo Park about a week or so ago. This is Buffalo Park last week. There's loads of yellow flowers out there. They're probably still there, so you have a chance, go check it out. Another impact is wetter monsoon, less fires, which is very nice. Doesn't have anything to do with the flowers, but I thought I'd put it on this slide too. So talking about the monsoon, our monsoon here in Flagstaff is part of the broader North American monsoon. It's not just here in Flagstaff, it actually covers a lot of Mexico, covers a lot of New Mexico and Arizona. And here's some different cities. This is average daily rainfall. for a city in New Mexico, for Tucson, for Albuquerque, and also for a farther east city. Tulsa is on here as well. And you can see that all of these places, or at least these first three places, have a quite pronounced uptick in summer rain. That's the monsoon. Whereas Tulsa is farther east and has a bit of a different pattern. And excuse this slide for having quite a lot of text, but just kind of an overview of how the monsoon works. And for a big system like the monsoon, and for a lot of weather stuff, it's complicated. So there's details here. I'm not going to talk about complexities, and also research is still being done. But here's the broad overview. Typically, wind in our monsoon region comes from the west. It's a drier wind. We don't get a whole lot of rain from it. In summer, we get heating in the southwest, and often heating can produce a low pressure system. And also higher pressure develops in the east. Now, air rotates counterclockwise around a low and clockwise around a high in the northern hemisphere. And if we have this setup, it means it's going to draw a lot of wind up from the south. And this is going to be nice, warm, moist air. And it's going to drop a lot of rain on this region. And also, for Flagstaff in particular, we have increased elevation, that transitional ridge area that I've shown you before, that helps produce rain here in Flagstaff too. And so this is a video that I'm about to play. This is water vapor. This is just 7.5 hours from a day in August in 2018. And it's just supposed to be a typical illustration of what a monsoon circulation looks like. So this is water vapor. These blue and green and red places, those are storms. Whereas the orange is dry air. So I'm going to play this. And this is accelerated over 7.5 hours. And you can see we probably have a high pressure system right here, and it's drawing air clockwise around it. That nice warm moist air is coming up from the Gulf of California, from the eastern Pacific. And the Gulf of Mexico is probably contributing some moisture at high levels too. And you can see how that rotation, we're getting a lot of storms, and it's dropping a lot of rain on these places. And I thought this was just really cool to look at. And here's an image of the monsoon region. Now, what this is showing is how much of the annual precipitation occurs in the summer. So places that are really blue mean quite a lot of their annual precipitation happens in the summer. They're pretty dry the rest of the year, and then they get most of their precipitation in the summer. And you can see that places down here get the vast majority of their annual precipitation in the summer from this summer monsoon. And actually, it's stronger down in Mexico than it is up in the US. And you might say, okay, Flagstaff, you barely even see it on this map. It's very, doesn't show much of up at all. That's because Flagstaff is getting a fair amount of moisture during winter snow as well. And a lot of these places aren't going to get hardly any or any at all winter snow. So we do have a decent monsoon here, but we're also getting winter snow. So we're not quite as reliant on the monsoon. Okay, and so the question is, why are some years wetter than others? This is the figure I showed before. Well, it's complicated. But one thing to remember is that monsoon intensity varies regionally. Just because we're having a strong monsoon here doesn't mean that the entire region is having a strong monsoon. So we have these green colors over Arizona. This is this year. It's a little bit out of date, but a lot of Arizona is above average rainfall for this monsoon. That's what those green colors mean. Whereas you can see a lot of New Mexico and Mexico, those brown colors mean that they had less monsoon precipitation than normal. So just to show you that the monsoon isn't just one thing that affects everywhere in the same way. So does El Nino affect the monsoon? Well, here's a figure. This is a little complicated. Here on the x-axis, we have the Nino 3.4 index, which is a measure of what El Nino is doing. Over on the right means that it's in El Nino. Over on the left means it's a La Nina, which is the counterpart of El Nino. And in the middle is just kind of neutral. The y-axis is summer rainfall percentage of average. So high values above 100 mean those years got more summer precipitation than normal. Whereas years down here mean they got less summer precipitation than normal. And so when you first look at it, there's a lot of scatter there. You know, we would like to see a nice linear relationship if El Nino was having a strong impact on the monsoon. But there's a little bit of relationship, a little bit of downward slope. So, you know, it indicates that, you know, maybe we get more rain during La Nina and less rain during an El Nino, but the relationship is kind of weak. So it's an element, you know, it's something to pay attention to. Hey, what's El Nino doing? Because it has impacts on a lot of the climate system, but it's not going to give you the whole answer. You know, there's lots of other impacts as well. So the relationship is weak. What's El Nino doing now? So this is a figure showing the last 20-some years. La Nina is below 0. El Nino is above. So here we have 2021. So it's currently a La Nina. So from the last slide, you know, maybe the La Nina is encouraging our wet year. And we can compare that to the past 2 years, you know, because we had such dry temperatures the past 2 years. Such dry precipitation. So 2019 was an El Nino, which from our last figure would suggest, hey, maybe that is encouraging drought. 2020 is maybe El Nino too, but really it's pretty neutral. So, you know, maybe just looking at these 3 years, it kind of is doing what you expect, but not to the extent. You know, the past 2 years have been so dry. You know, if this amount of El Nino is going to produce the driest years on record, what's this going to do? And, you know, I don't know offhand what that year was, but these ones were drier. So it's not going to be a clear relationship. And, you know, there are other impacts on monsoon. I'm not going to go through anything else. It's complicated. It's still kind of under research. But maybe El Nino is giving you a little bit of indication. But I did want to talk about Flagstaff snow. The snow is fun. I like snow. And here is 2021. We were looking at this before. And you can see that we had a fair amount of snow since January. I'm going to go ahead and move this over so we can get the end of 2020 as well. So I just want to show the entire winter spanning between the end of 2020 and the beginning of 2021. And so we had a fair amount of snow after the new year, not too much before the new year. So how does last year's snowfall, this past winter's snowfall, stack up to previous years? As before, we have one of these cumulative maps. Now this one runs for the entire year, starting in the middle of the year, in July 1st, and running through the end of the year and into the first half of next year. So it goes from July 1st to July 1st, so the entire year. And that's just so I can make sure to include all the snowfall, even though it's not really falling during the summer. And so, okay, we have our snowiest year here in 1972-73, which is over 200 inches, maybe around 210 inches, which is quite a lot. We have our least snowy year in 1933-34, which looks like barely at all, maybe 10 inches the entire with it. And, you know, our normal snowfall based on this data, this is 62 years. It doesn't cover every year. Some of the years with missing data, but it's 62 years at the airport. Based on this, you know, our typical average snowfall is about 92 inches. That's close to the normal figure that people give, which is 100 inches. Probably depending on exactly what years you're looking at, that average is going to go up or down. So how do you all think last winter compared with normal? Normal? Any other ideas?
Normal?
You guys are right. It's pretty
Oh,
much
wow.
right on the money. And as we saw before, the first part of the winter, we didn't get a whole lot of snow. But then since the new year, we have gotten some big snowfalls, which put us almost exactly on the average. So it's typical. Let's go back a little farther in time to 2019. So here's 2019. Here's the year. You can see how dry that monsoon was. It didn't really relieve much of the temperatures. But I'm a little bit more interested in this event in February, where we got 35.9 inches of snowfall in 24 hours. So from midnight to midnight, we got pretty much 3 feet of snow. And if you were here then, I'm sure you remember it, because it was a lot of snow. I didn't drive anywhere for 3 days. I don't think I would be able to get my car out for the first day or two. And it was quite an interesting event. And you can see it comes along with very cold temperatures. Like the rain helps cool temperatures, snow often comes along with cool temperatures as well. Often we have lots of clouds. Once the snow is on the ground, it can reflect sunlight back up and not warm the surface. So you can see how kind of the big snow events go along with colder temperatures, which is, that makes sense. It snows when it's cold. And here's a headline from that day. We get 35.9 inches of snow. Here's from the National Weather Service. Here's our record. Payson had their 3rd highest 2-day snowfall. Sholo had a 1-day snowfall record as well. So quite a lot of snow. And I went out that day. I took some photos. I just thought I'd share some of these with you. Here's the mail truck still delivering mail. This is as the snow is coming down, so it would increase a little bit more after this. Here's the woods behind where I live. Here's my apartment complex. You can see these cars, and this one's mine. I did that thing where you put the windshield wipers up, but I don't think I could get this car out for a couple days. And I didn't try, I had other things to do, like exploring the snow. There are big icicles. I often find that Flagstaff produces great icicles if you go around in town when you have a good event for it. Here's a stop sign, another sign. You can see, I think they pushed the snow up against it, or maybe the wind pushed it up against it, but quite deep snow. But here's the radar from that event. This covers about 2.5 days. I'll wait for it to start over again. But you can see just how much of the state that it covered. Okay, so here it's coming kind of down the coast. It's kind of looping into Arizona. You can see that quite a lot, even down in the valley. I think as far down as Tucson got a little bit of snow, but it was quite the event. I think I drove down to Phoenix probably a few days or a week after this event. You could still see snow on the ground as you head down there. And just if you think about how much water is involved in all this snow spread across all the state, kind of staggering. So just to explain what's going on in this event, here's a meteorological map. So these are winds. The winds are these blue barbs. Basically, it's going towards the pointed end. So the wind is kind of coming down the coast and swooping around across the country. And also, wind typically follows these height lines. The height lines, it's essentially a pressure difference. Winds tend to go along pressure boundaries. So you can see this is from the morning of February 21st. You can see that air is coming down from the polar regions, bringing cold air with it. And it's coming down the coast. I'm picking up some moisture, and then once it's kind of down near the border of Mexico, it's turning and heading up through Arizona and through the rest of the country. So it's bringing that cold air, and it's gathering moisture over the ocean. And then once it gets over land, especially Arizona, where we have our nice ridge from before, it's going to drop that snow. Because for snow, those are kind of the three elements that you need. You want cold air, you want moisture, and you want something to lift the air. Because if you can lift the air gets colder, and it can't hold as much water anymore. So that moisture is going to fall out. So yeah, we have cold air coming down from the north. We have moisture being picked up over the ocean, and we have lift once it comes over the continent, the land. And you can see the next day, this is February 22nd in the morning, and about the same thing is going on. So those processes are working together to bring us a lot of snow. So if we return to El Nino for a minute, I told you that El Nino years maybe give us a little bit drier monsoon. However, in the winter, maybe they're doing the opposite. So these maps show difference from average snowfall in the 10 strongest El Nino events and in all El Nino events. So basically the blue colors mean we're getting more snow in those years than normal. Whereas the brown means we're getting less snow in those years than normal. So again, I don't think this relationship is super strong, but it is a relationship. It's something to keep your eye on. That El Nino, even though it produces a drier monsoon, might also produce a wetter winter. And there's some evidence that here in Flagstaff, our winter precipitation and our monsoon are kind of oppositely related. Again, it's not the strongest relationship, I don't think, but it's something to keep an eye out for. So if we have a very dry winter next time, maybe you can keep your hopes up that, hey, maybe we'll get a nice strong monsoon. So I think Flagstaff weather is great. I do want to jump into a couple stories from history, though, because I think fascinating things have happened in the past, kind of that have a weather tint to them. And so I want to, fairly quickly tell you guys two weather stories from history. This is what I said. The world is a big place. There's lots of interesting weather stories. So the first story, I have a question here. Predicting the weather with leeches, which doesn't sound like something you would think to do, and yet somebody tried to do it. So in the 1800s, a man named George Merriweather invented a device to hopefully predict the weather using leeches. And he called this machine the Tempest Prognosticator. And you can see it here. This is an illustration of this device. And here we have a zoom in at the bottom. We have these 12 different jars along the bottom. In each of these jars is a leech. You're thinking correctly, those little wiggly animals. One of them is in each jar. And the idea here, at least George Merriweather's idea, is he had heard that these leeches respond to storms. That when pressure drops, which often occurs before you get a storm, the leeches will notice the pressure drop. And they become a little bit more active. And so if they notice the pressure drop and they become more active, they might wiggle to the top of their jars and dislodge a little hook up there, which dislodges this wire. The wire goes up to the top and rings a bell. The idea is you have these 12 leeches in jars. If more than one of them, if multiple ones wriggled out and ring the bell, then you have a storm coming. And George Merriweather, he liked this idea. He tried to make it successful. He went over to different lighthouses and, asked if they wanted to buy one. And there's some anecdotal evidence that maybe it predicted some storms, but really evidence isn't very good. So who knows if it did anything useful at all. Besides, we already had barometers at that point. Barometers, we still use barometers in different forms today. Barometers are relatively small, they're more accurate in telling you the pressure, and they don't need to be fed, which is a definite bonus here. So, historical story number 2, and I'm just telling these because I think they're interesting, I think they're fun. And we can look at the world beyond Flagstaff. This is one event that I think is really fascinating. That about 100 years ago, a little over 100 years ago, 2 groups of people tried to be the first people ever to reach the South Pole. It's in the middle of this big icy continent, difficult to get to. Nobody had ever made it to the South Pole before. The 2 groups tried to be the first ones there. And they end up, for one reason or another, doing it at the same time. This was in 1911. And so I say race, it wasn't a foot race. Nobody said go. One group did start earlier, taking their chances with the colder weather. Because you want to go into the interior of Antarctica during the warmer season. You want to go in during summer. If you try to go too early and it's still too cold, that's bad. If you're stuck in the interior of Antarctica when it starts getting cold again, that's also bad. So you kind of have a window of the year to head to the South Pole. And the Norwegian, Roald Amundsen, made it there first in December 1911. And I say December, but remember the seasons are opposite down there. So December is really the summer down there. So that's a good time to be there. He traveled there with 4 companions, sleds, and dogs. And I bring this up because Antarctica fascinates me. It's our coldest continent. It's our windiest. It's bigger than either Australia or Europe. And we just get extremely cold temperatures there. And actually, one detail about those cold temperatures, if you're stuck in Antarctica when it starts getting cold, these people use sleds with skis on them. We ski here, and normally when you ski, it provides a fairly smooth ride that you're able to ski on the snow surface. Because I think what's happening is that the pressure from the ski is providing a little bit of melt. It's slightly melting the snow, and it's providing you lubrication to speed along. Below a certain temperature, that doesn't happen anymore. So if it gets too cold and you're stuck in Antarctica, those skis become much harder to pull. It becomes more like trying to pull skis on sandpaper. So they didn't want to be stuck in Antarctica. And this is Roald Amundsen. This was the first guy to make it there along with his companions. This is an older picture of him. He was a bit younger when he did the type. But I think it's such a cool place. I just wanted to read a little bit from his book about him reaching the South Pole. So he says, this is translated from Norwegian, by the way. At 3 in the afternoon, a simultaneous halt rang out from the drivers. They carefully examined their sledge meters, and they all showed the full distance, our pole by reckoning. The goal was reached, the journey ended. I cannot say, though I know it would sound much more effective, that the object of my life was attained. That would be romancing rather too barefacedly. And he says this because he's Norwegian. He's up near the North Pole. He had dreamed as a kid of being the first person to the North Pole. And yet, before he was able to set out for the North Pole, 2 different groups of people both claimed that they'd made it there. And it's likely that at least one of them was wrong or deceptive about it. And it's possible that the other one was incorrect about reaching the pole. So it's possible that the North Pole still hadn't been reached at this point. But he said, let's not deal with that. I'll go to the opposite end of the earth instead. So that's why he says it's topsy-turvy, because he's pretty much exactly opposite from where he wants to be. And he goes on, I'd better be honest and admit straight out that I've never known any man to be placed in such a diametrically opposite position to the goal of his desires as I was at that moment. The regions around the North Pole, well, yes, the North Pole itself had attracted me from childhood. And here I was at the South Pole. Can anything more topsy-turvy be imagined? And that's from his book. And maybe these stories seem like a little bit of a tangent compared to Flagstaff weather, but I think they're neat. I think seeing how different the climate can be in different parts of the world is fascinating. And also the different things that people have done through time to try to measure the weather. As with the tempest prognosticator, we used leeches. And yeah, it didn't work out. It didn't become popular, but it was inventive. He was trying. So I guess I'll wrap up. I think the weather is amazing. Here again is a picture that I showed at the beginning. This is a supercell thunderstorm with a lightning bolt coming out of it. And it's beautiful, and it's dropping rain, which is important to how people live. But also it shows, the potential dangers of weather. And we have dangers here too, especially from flash flooding. Don't be any of those slot canyons when our monsoon is raining, because it can cause flooding. Even if the thunderstorm is out of sight somewhere else, it can cause flooding, and it has caused deaths. So weather is this multifaceted thing. It's important. It's kind of central to how we live our lives and where we live. And it's beautiful and it's dangerous, and it's all those things. I'm just going to give a little pitch for myself. I said in the beginning that I'm also an author. I like weather and I like mysteries like Sherlock Holmes and Agatha Christie. And I've written a couple of weather-themed mysteries. So here's two of them. This is the first one. This is the new one that just came out this year. It's called The Weather Detectives. It combines a fictional Caribbean mystery with real weather and science to inspire young readers. So for instance, those two stories that I just told about the tempest prognosticator and the race to the South Pole, both of those are in there, as well as a kind of this central fictional mystery that takes place down in the Caribbean. And yeah, they have the same main characters, but you can read them in either order. They're for sale, so don't want to dwell too much on it.
I will include information about them though, so if anybody's interested, you can.
Yeah, great. And I have a little website that I put together. It's weatherdetectives.org. And here you can find, some weather projects, building a barometer, doing snowflake photography, estimating the distance light, which I think is fun, as well as cloud shapes. Here's clouds that from right here in Flagstaff. It's taken from Buffalo Park. Like this one looks like a duck, I think. And there's other weather photos and some weather history on this website. So, it's aimed more at younger people, maybe at middle schoolers, but I think it's fun for the whole family. So if you're interested, go check it out. And with that, I will wrap up. So I hope you've enjoyed hearing about Flagstaff weather, seeing some photos of storms other places, and learning a little bit about some of these unique and strange historical events.
Thank you.